Hi guys, this is Math 116, section 3.3, and in this section we are looking at the Gauss-Jordan elimination method. Such a fancy sounding name, doesn't it? It sounds like some sort of strange child experiment from the Victorian era. But no, it is actually a method of matrices, manipulating matrices to solve systems of equations. So, these problems, I call them the old growth terminators because you're going to go through a lot of paper. They just take so much space. Here is, and I'm going to jump right into an example and show you how to work these problems. Here's the gist of what we're doing. Suppose we have a system of equations like this. X plus 2y plus 5z equals negative 4, and 2x minus 2y plus 4z equals negative 2, and one more. Yep, sorry, I was going like negative y. No, it's a positive y minus 3z equals 7. So we have a system of 3 equations and 3 unknowns, 3 variables, x, y, and z. And our goal, the ultimate goal of this section, is to solve these problems so you have x equals something, y equals something, and z equals something that makes all of these equations true. And yes, in chapter, section 1 point something, 4? 5, 6, we did substitution methods. So you could do substitution methods where you let z equal y and then you plug in, but that's pretty tricky. And so this is an alternative to the substitution methods. And when you use your calculator, this is actually much easier. So when we do it by hand, it's a bit cumbersome. Yes, we're going to do it by hand right now. The first thing we're going to do with these problems, the first way you tackle it is you want to line up all of your equations so that you have x in one column, y and z. Doesn't really matter the order, but typically we put them in alphabetical order, x, y, and z, and all of the equations right here have a number, a constant. So if your, thanks Fuji, if your equation is in some other form, line them all up this way. So you have x, y, and z. The second step is to do an augmented matrix. Aren't these fancy English words? An augmented matrix. And the augmented matrix is just making a matrix out of that system of equations based on the coefficients. So, first column is going to be the coefficient of the x term. You have 1 times x, 2 times x, but there's no x here. That's okay. We can think of that as 0 times x, right? Plus y. So the first column will be 1, 2, 0. 1, 2, 0. The second column is the y term. So we have 2, negative 2, and this is just plus y, so that's going to be a 1. So it's 2, negative 2, and 1. 2, negative 2, and 1. The z column is going to be 5, 4, negative 3. Do you see what I'm doing here? 5, 4, negative 3. I'm writing matrix, and I draw this line. The line just basically says this next one are the coefficients, and the last column is going to be these coefficients. Minus 4, minus 2, 7. Minus 4, minus 2, and 7. And cleverly, I wrote this problem because I'm so clever. This is now question number 9 on the 10th edition textbook. So our goal for these problems, I know I told you the goal was to write it like this, x, y, and z. Yes, that is true. But in order to write it x, y, and z, if we can change this matrix through manipulation so that it looks like this, instead of 1, 2, 5, if it was 1, 0, 0, and then a line and some number, this is our goal. If we can get it to look like this, then we will know that right there, that x is this number, the y, which is here, is going to be this second number, and the z is going to be this third number. So now we're going to manipulate this matrix. We're going to add and subtract the rows in combinations to try to get it to look like this. I call it the identity matrix. I don't know what the book calls it. We want the 1s on the diagonal, like this, 1, 1, 1 on the diagonal, and the 0s everywhere else. So now begins a series of manipulations. And the first thing I'm going to do, I say, okay, I like having a 1 there, but I don't like this 2, so I'm going to try to get rid of the 2. My goal now is to get rid of this 2, and I'm going to do that by taking negative 2 times row 1. So if I take negative 2 times row 1, I'm going to get a negative 2 there, and I'm going to add it plus to row 2, and then I'm going to make that the new row 2. So that essentially says put it in row 2. So here's what this looks like. I'm going to leave row 1 the same. That's 1, 2, 5, negative 4. See, it takes up a lot of space and time. So when you take negative 2 times row 1, this becomes negative 2, negative 4, negative 10, and positive 8. Because negative 2 times negative 4 is 8. Oh, these signs will mess you up. So we add them together. Negative 2 plus 2 is 0. Negative 4 plus negative 2 is negative 6. Negative 10 plus 4, negative 6. 8 plus negative 2, positive 6. And then I'm just going to leave the third row the same. Okay, we're getting close. Now I'm going to do one more thing on this page. I like this, it looks good. See, I'm getting closer. I have 1, 0, 0, 1, 0, 0. Yay, that makes me happy. I'm going to get rid of these 6s. I don't like having all the 6s there because I want 1s. So now, the next step, I'm going to take, in order to get rid of those 6s, I'm going to divide, what is your book? Oh, your book does something different. Oh, why did they do that? I was going to say I'm going to divide this row 2 by negative 6. Okay? So, this thing now becomes leaving row 1 the same. You might sing yourself a little song. That's the Augmented Matrix song. So minus 4, 1, 2, 5. So 0, I'm dividing this whole thing, everything divided by negative 6. So divided by negative 6, divided by negative 6, divided by negative 6, like this. This is pretty boring to watch. maybe you're also watching Breaking Bad or something while you're watching me do these videos. 1, 1, negative 1, and then 0, 1, negative 3, and 7. So again, my goal, I'm taking this matrix that was from the coefficients, and I'm going to start manipulating, adding and subtracting the rows until I get something that looks like this form. So now I'm going to rewrite this matrix on the next page. Hold on. I'm trying not to make a mistake on these videos. So I like this, the fact that it's 1 and 1, but I don't like having the 1 here, because I want it to be 1, 1, 1 all the way down. So now I'm going to say, well, I'm going to get rid of this guy. This is my target. He is in the center of my attention. I want to say my scope, but so I'm going to take negative row 2, right? This one, row 2, negative row 2, and add it to row 3, and that is going to become, I'm going to put it in row 3. So that's going to look like this. So the first row is going to stay the same, not going to do anything to that. Negative 4. Some of you may ultimately combine these steps and do a couple of steps at once, like this. So negative 2, or excuse me, negative row 1 is going to be negative 1, positive 1. So now I'm going to add it. I'll make the new one here. 0, negative 1, positive 1, 0, negative 1 plus negative 3, minus 4. 1 plus 7 is 8. Huh? You see what I'm doing? Okay, I like it, but I don't like this negative 4 here. Remember, I want 1s all in the whole column. I don't like this negative 4, so I'm going to divide both of these. I'm going to take row 3. I'm going to divide it by, or multiply it by negative 1/4 to get rid of that. So, my new matrix is 1, 2, 5. I like to do one row at a time. Some people double up and they do a couple of row manipulations for each one, but I make enough mistakes as it is. So this new row becomes, I'm dividing this times negative 1/4, times negative 1/4, times negative 1/4, times negative 1/4. That becomes 4 times negative 1/4. 0, 0, 1. See? And then this becomes negative 2. Alright? Okay, we're getting closer. Do you see how we're getting closer? I have 1, 1, 1. That's all good, and I have zeros here. But these guys right here, these are my problems. I don't want those. I don't want a 2, 5, and a 1. I want these to be all zeros. So, I'm going to deal with them. We're going to get rid of them. But now that you have 1s in these columns, these are much easier to get rid of these guys. So you want to get 1s on the diagonals first, and then you can easily get rid of these, and I will show you how. Okay, let me rewrite this matrix. Hold on. Okay, that one that I have. So I'm going to start by trying to get rid of this 2. That 2 right there, he's my problem. He is now in my sights. I'm trying to get rid of this guy. So I'm going to take this row, because it has a 1 in it, and take -2 times that row and add it to this row, and that will get rid of that 2, because I'm trying to think of what do I have to add to this 2 to get rid of it. So I take -2 times row 2, add it to row 1, and that becomes my new row 1. Like so. And sometimes I write it like this. That becomes -2 times 0 is 0, -2 times 1 is -2, 1 times -2 is -2, -1 times -2 is +2. So I write the little numbers that I'm going to add so I don't get as confused. So my new row 1 is now, I'll make it yellow, 0 because it's 0, oops, excuse me, 1 because it's 0 plus 1. -2 plus 2 is 0. -2 plus 5 is 3. And then 2 plus -4 is -2. And then here you have 0. Just going to leave this the same. I'll make it white. 1, 1. Haven't done anything to this. And row number 3 stays the same. And haven't changed anything. I'm only changing one row at a time. So that looks good. So now, here's what I don't like. Now I don't like this 3 and I don't like this 1. Can you see how I'm getting close? I'm getting so close. So in order to get rid of the 3, now we can use this row. See how there's a 1 here? So it's easiest to use this row 3 to get rid of the 3 because there's so many other zeros. So you take -3 times row 3 and add it to row 1 to get rid of that 3. Right? Trying to get rid of this guy. Like that. So, and that becomes our new row 1. So here's what we're doing. We're changing row 1 again. So when I multiply this row 3 times -3, that becomes 0, 0, -3, that's a -2, so that whole thing becomes 6. So -3 times -2 is 6. So adding them up. This changes 0 plus 1, 0, 0 plus 0, 0, -3 plus 3, 0. That's what I wanted. 6 plus -2 is 4, right? Happy times. And then all these other rows stay the same. I haven't done anything with them. 0, 0, 1. Some of you will combine these steps and do a couple at a time. Okay. Now I'm going to rewrite this one. You see if we have one more to go. Maybe I'll just do it on this page. So this, we only have one problem guy, and he's right here. That 1. If he was a 0, we'd be done. So, in order to get rid of this guy, we're going to take negative row 3, -1 times row 3, and add it to row 2, and that becomes our new row 2. So we're going to take this -1 and add it up there. So we want -1, negative that times this row is -1, -1 times this is +2, huh? I like to write them below so I don't make as many mistakes. So, I'm leaving this row the same because that row is perfect. This second row, I have 0. I should make a 0 here. This new row becomes 0 plus 0 is 0. 0 plus 1 is 1. -1 plus 1 is, I almost said 1. It's 0. That's the point. 2 plus -1 is 1. And then this other row, I'm not going to change that. The third row stays the same. This is very strange, and these are all matrix manipulations, but I am happy now because this is in the perfect form. I am done. So I'm going to rewrite this on this page. So here is our final solution. We have 1, 0, 0, 0, 1, 0, 0, 0, 1. We've manipulated those rows, and you should get this. And you might choose to do it in a different order. It doesn't matter what order you do it in. This should always be your final answer, no matter which way you add and subtract. Finally, finally answer. No matter how you add and subtract the rows, this will be your final augmented matrix. So, now where it's really easy. This is x, this is y, and this is z. So we say x is equal to, there's a 1 in there, 4. Y is equal to 2. And z is equal to -2. So you can imagine if you could just put this part right here If you could just stick this into your calculator and it would just spit out this answer, it would be a very fast process. So, oops, y equals 1. Y equals 1, 1, 1, 1. So that's why we do it, because the calculators and computers can do this quickly for us. But I want you to know how to do these processes where you manipulate the rows to get your final answer. So I wrote up a few of these, and I expect you to look at them and let me know if you have questions. I want you to be able to use your calculator to check your answers. Calculator to check your answer, but you're going to have to do one and show your work on a test. And if for some reason you love this and you say Gauss-Jordan method is what made me love math, please tell me, because I have not yet met you. Most people don't really like this very much. Okay, let me know what you think.